Hopefully you've had a chance to work on the project proposal. It's due today, Tuesday, April 7 by 11:59 p.m. I know some of you had some issues trying to come up with a problem to solve. You can think of the previous assignments you've worked on where you created custom data requests. You can look at the problem to solve as the question that you're asking of the data. If you still have issues coming up with a problem to solve, go ahead and submit the proposal with the best effort on trying to answer that question, and then we could work together to further refine it. By now, you've probably noticed you're running queries or the same queries over and over again, and it can get cumbersome where you're having to retype the queries or having to look for it and copy and paste the query. Well, to help solve that inconvenience, we're going to cover views today. Views are a way to save these queries, especially for frequently used queries. And the way you could look at views is think of it as a virtual table. You query it just like a normal table. You can also join into a view like a regular table, or you can use multiple views to join into each other. You can also update views, insert into them, and delete from them. But there are a few limitations to that. It's not like a regular table. Here's the syntax to create a view. You see the or replace option there. It's probably easier on your end, and you'll see why, to just say create or replace view every time you create a view. The or replace is optional, but as you're developing views, it's easier to add it in, so that way it just automatically overwrites the existing view. So looking at this, it's pretty simple on how to create a view. All you have to do is just add that first line. Everything else is the same. All you're doing is just adding your select query to the bottom. There's this principle in programming, dry, don't repeat yourself. You don't want to have to reuse the same code over and over again where you can just code it once and then not have to code it again. Same thing applies to SQL. You want to avoid wasted effort. You don't want to have to duplicate your efforts. Okay, so you write a query and then just access that query as needed instead of writing out the keystrokes each time you need the results of that query. So this saves time, and then it also prevents you from making careless mistakes, especially as the queries grow bigger. Just write it once, QA it, know that it works exactly as you want it, and then query that view whenever you need those results. Why do we need views? Well, here are 4 commonly seen use cases for views. So as kind of mentioned earlier, these are for frequently used queries. Instead of having to code them each time, just access the view. You want to use views for security reasons. Some tables can have sensitive information, and people within the organization, they have different privileges. Not all people should see all the information. We could also use views to conceal complexity, meaning you don't have to write these complex queries every time. The views will simplify it, especially for somebody who is less technical, maybe a junior business analyst or a new developer. It's easier to just give them the view instead of having to explain to them, well, this is how you get the data. You have to join into these tables and access these columns. And then the last reason we're going to cover is for aggregation. This is especially helpful for BI type purposes. You can aggregate the data into a view instead of having to specify it in with your aggregate function and group by every single time. We're going to cover an example for each of these reasons to use views. Go ahead and download the SQL View template notebook from Brightspace, and we'll use that notebook to fill in the examples. First, I have to load the SQL extension to allow us to run MySQL within the notebook. We're going to connect to the LMU build sakila database. You can fill in the values here, or you can copy and paste the connection string from the previous notebook. Confirm that you're connected. We have the view syntax here for our reference. This first example is going to show how we can use a view for a commonly used query. Many people across different departments will want to know, well, who are our active customers? So we'll create a view to give back to us all the columns for our active customers. It's good practice to test out the query first before creating the view. So test out what is that SQL statement to add to the view. I'm going to write the query to select all of the customers, all of the active customers. Spot check the results. Looks like I got all the columns, and in the active column, it's all showing one. Now that we've confirmed the results for the SQL statement, we can add the create code. So create view active customer as, and then I like to indent the SQL statement to make it a little bit easier to read. And I'm excluding the or replace for right now, just so you could see the difference between having it and not having it. It should show 0 rows affected. There should be no errors. To confirm that the view works, you're going to select from the view. It looks just like our previous query, but now we're selecting from the view and it shows the exact same results. A note on naming convention. I had named the view active customer, but you may see elsewhere, whether in tutorials or maybe at a company, that they may prefix or add a suffix to say that this is a view. So it might show view underscore active customer or active customer VW. I would recommend against that because sometimes it's more efficient to create the views into actual tables for performance reasons. And if you do that, you don't want to have to update your code all across your application if it says active customer view. If it's just named active customer, it's transparent to the code. You don't have to go into your application and replace out the view with the new table name. For our second example, we're going to build on top of this previous query, but show how views can help with security. Okay, we're going to limit access to certain columns, and then also we're going to hide sensitive information. So what we want to do is display only the active customer's first name, last name, and email. We'll do that first, and then in the second step, we're going to obscure the email. But first, let's just get the first name, last name, and email. I'm going to test out the query first. Okay. Only first name, last name, and email. That's all we want to return in the view. We'll add the create view statement, but here I'm going to, actually I'll just write create view first and we'll see what happens. Create view active customer as, and then indent the SQL, then run it. Okay, we get an error here. It says table active customer already exists. It's really a view, but MySQL still calls it a table. To get around this error and not have to drop the view and then recreate it, we just add or replace. Okay, it'll just replace the view's definition. Okay, we're going to verify that this worked. So we're going to select from the view. We use the same view name, but now it only shows the first name, last name, and email. For some users, it may not be important to know, okay, what is the customer ID or the store ID or even the create date or the last update date for the customer or even the address ID. We can limit the query to only select the columns that are clear and understood and needed by the end user. But if there is a column that comes back, but we don't want to reveal the entire value for privacy reasons or maybe even legal reasons, we can obscure it using a string function. So if you recall, in the previous lecture, we covered string functions, and one of the string functions is able to extract parts of a string. And that function that we use is the substring function. Before adding to the create view definition to obscure the email, we're going to test it out here first. For Mary Smith's email, we want it to look like this format. Just the first two letters and then a placeholder here with asterisk and then showing the last four characters. I'm going to build on this step by step. First, I have to get the first two characters. I'll use the substring function. The email is the column. Start at the first position and then get two characters. Let me test that first. Okay, got the first two letters. And then I want to test out getting the last four letters. We don't know how long each string is. So to just get the last four letters and not have to know the starting point, we can use a negative value. This gives us the last four characters. And we want to put this all together, but in between, we want to have asterisk. We'll use another string function for this, the concat function. Add the closing parentheses here. I'm going to indent also. And then in between, I'll add in 5 asterisks. So it's regardless of how long the string is. And I'll alias this as the new email column. Okay. So we get exactly the format that we wanted. We're piecing together different string functions in order to obscure the email. We can take this part of the query and then add it to our view definition. I'll take out this email, and because it's such a long chunk of code, I'm going to add it to its own line, its own new set of lines. And because the replace is in there, it's just going to overwrite the view, and I'll verify the view here. And what I should expect to see is that the email is obscured with the asterisk. There you go. In the previous example, we excluded certain columns to not confuse the user, but we could also use views to minimize the coding overhead. Okay, so to minimize the complexity of the query that, let's say, a business analyst has to run, especially as more tables are involved, we can not have the user perform these multiple joins. So we're going to find the actors for a specific genre, a specific category, but we'll use a view for that. Because as we know that we have to join in multiple tables to get the actor information for a specific category. And we also want to be able to select the film title. I already listed out all of the different tables involved here: film, film actor, actor, film category, and category. So that's a 5-table join. And for some users, being able to join in 5 tables might be hard for them to juggle in their mind. Go ahead and write the query to select the actor's first name, last name, the genre, which is the category name, and the title. So write a query just to do that by joining in these 5 tables. I'm going to write the select statement first. I'm going to alias the category name as genre, just to lessen the confusion, because it says name here and that might be confusing if that comes back as a column header, especially when we're dealing with names of people. Then we're also going to select the film title. Selecting from the film table, and because there are so many tables, I'm going to alias the tables so that I don't have to write out the entire table name. Join into the film actor to figure out who are the actors associated to each film. Alias film actor to FA. And we're joining on the film ID. Then we're joining into the actor to get the actor names. And we're joining on the actor ID. To get the film categories, you have to join into the film category table. We're joining the film category table into the film table. Lastly, to get the actual text name, the genre of the category, you have to join into the category table on the category ID. Let's see, I think I have. Oh, it's category ID. We get the actor's first name, last name, and the genre of the films that they're associated to. Looks good. Going to add the create or replace view statement. And we'll call this film actor genre. Run this line, 0 rows affected, no errors. I'm going to verify this view by creating a list of comedy actors. I'll get the first name and last name from this view, from the film actor genre view. And we can pass in where conditions. So we only want comedy actors. And I aliased the category name to genre, so we have to use that alias name. these are all the actors for comedies. So now we can also add in the film title. I'll also add in the genre just to see it too, to spot check. So Richard Penn is associated to the comedy Airplane Sierra. To list out all of the views for the database, we can run a show full tables query, but adding to it a condition to look for a table type equals view. We only have one view in here and it's showing the active customer view. If we want to view the definition for the view, we can run show create view active customer. Oops, forgot the SQL. And it is in this part of the results that you can see the view statement. It translates it for you, but all it's doing is it's showing all of the different columns. And here it's saying from customer and then with the where condition. The show create statement is just like show create table, but it's just show create view and then the view name. We can use views to return results that are already aggregated. So meaning we're using an aggregate function and a group by. Many BI applications, when they're querying a database, they're querying views, but views that have aggregate data. So that way the analyst does not have to figure out, okay, how am I going to group this data and what are the column names I need. When I was creating access to the database for BI users, I'm usually just giving them access to views. So some of the BI applications that connect to databases and specifically connect to views are things like Tableau, which we've seen before, Power BI, Looker, Cognos, Domo. These are all BI applications that connect to databases. Okay, so we're going to aggregate some data. So let's say if we wanted to create a monthly report to help managers decide, okay, which films do we want to add to inventory? Because we want to see which films are doing well in terms of rental revenue. So we're going to create a view that returns aggregate data based on the rental date, year, and month, and it'll show it based on the category, and will show the aggregate of the total rental revenue. This is also another example of how we can hide the complexity behind a multiple table query. All right, so what are the tables that we need first? To figure out. So we need the payment table to get the rental revenue. We need the rental table to see the films that were rented. Have to check the inventory table because this tells us what are the films that are in inventory that can be rented. We need the film table to get the film category, the film genre. We need the film category table. We need the category table to get the name of the genre. So we have here a 6-table join. So this is going to minimize the complexity overhead to write this query to get aggregate data. We only want data per month. So we can group by part of the rental date column, specifically just the year and the month. We could use a date function to extract the year and the month, but I find it easier to use a string function. So we're going to use the left string function to just get the year and month that we're going to group on. So select left on the rental date column,
And we only need 7 characters because that gives us the year and the month separated by a dash. I'm going to alias this as rental date month. I'm going to get the genre name. I'll alias this as genre. And then the total rental revenue. So that's going to come from the payment table, which is amount. Okay, so we're going to select from the payment table first, alias it, and we'll join the payment table into the rental table. And then we need to join into the inventory table. Based on the inventory ID that's in both the rental table and the inventory table. Join into the film table. On film ID between inventory table and the film table. Film category table to figure out which films belong to which categories. Oops. I need to join in, got ahead of myself, need to join into the film table. So film to film category. Then now I can join on category ID between film category and category. Close this out with a group by, and we're grouping by the rental date month and the genre. So we want to know what is the total revenue for a specific month and genre. Take out the notes here. All right, so we see the year and month, the genre, and how much total revenue was generated for those 2 columns. Let's add the create or replace view statement. We'll call this view sales by film category. Let's double check our work. We'll select all the columns from the view. For rental revenue in August 2005, and then we're going to sort it by the total rental revenue. Called the date column rental date month. August from 2005. Order by the total rental revenue. Running this query shows that we don't have to do any of these joins, this 6-table join, and have to do the aggregate function. We could just tell an analyst, if you want to get sales by month for a specific genre, you can pass in the month, or you can query it by genre too. So if I just want to see for the travel genre, you get $1,244 in rental revenue. Views are updatable, so you can insert into them, update, or delete from a view, but there are some caveats. The select statement in the view, it can't have aggregate functions. You can't do a distinct, you can't do a group by or having, a union all. Can't have a left join or outer join. You can have a regular join, a normal inner join. And you cannot have a subquery in the select or from clause. You can have a subquery in the where clause, but you can't have a subquery in the select or from clause. For one of the customers, Linda Williams, we're going to update her last name to Kennedy. Let's say she was recently married and wants to change her last name. So instead of directly updating the customer table, we're going to update the active customer view. Let's just double check first that she exists in the table so we can see the change after we make the update to the view. Let's do select star from active customer. First name equals Linda. Last name equals Williams. There she is. Okay, we can update this select query for our update statement. Whenever you're modifying data in an update or delete, it's always good practice to run your select statement first so you know what you're actually changing. So it's good to have the where statement in place already. We'll just modify this query. So we're going to update the active customer view and then set her last name to Kennedy. We'll confirm the change in the view. Forgot the magic command. Her last name is showing as Kennedy now, and we're selecting it from the view after updating the view. And we can confirm that the table that this view was sourced from was also updated. So the tables that views reference, those tables are known as base tables. So we're going to check the customer base table to see if it was also updated. Okay. See her last name is updated there too. So you can update views, but remember there are some caveats to it. But if you are a junior level analyst, you most likely only have read-only access to these views. It's highly unlikely that you're going to have permissions to update, delete, or insert from a view.